section 5.5, trigonometric equations. And here's a third example where we're solving an equation. Sine of 2 theta equals square root of 3 over 2, where theta is from 0 to 2 pi, including 0. Now, when we think to undo this equation, we want to kind of think about the sine inverse, but we're trying to find the sine inverse of 2 theta, not theta. So we're going to have to look at a larger possibilities, more possibilities than this theta. So we're going to expand these possibilities by multiplying by 2. So 2 times 0 is 0. 2 times theta is 2 theta. 2 times 2 pi is 4 pi. Now we get the correct domain to look at for 2 theta instead of just looking at the domain of theta. Okay, so we're going to have more possibilities. Now, to look at the solution, one way to think about this is you want to think about when is the sine of 2 theta equal to square root of 3 over 2. So one informal way to kind of process this is to take sine inverse of both sides. And I say this is an informal because this will get you some of the solutions, or it'll get you a quadrant 1 solution. But we have to make sure that we're covering all solutions. Anytime you do something to an equation, you want to do it to both sides. So sine inverse cancels the sine. So you have 2 theta equals the sine inverse of the square root of 3 over 2. So we can go ahead and find that value in your calculator, and it's going to give you the quadrant 1 angle, which is pi over 3. So it gives you this quadrant 1 angle, pi over 3. So pi over 3 is one of these solutions. But we also know that the sine is positive in quadrant 2 also. So we're going to need another solution that has the same reference angle. See, the reference angle for this angle right here in quadrant 2 is pi over 3, but the angle itself is 2 pi over 3. And the reason that is over here is pi, and pi can be rewritten as 3 over 3. So we're just going pi over 3 shy of it. So now we have 2 of our angles, 2 of our solutions are pi over 3 and 2 pi over 3. These are solutions that are between 0 and 2 pi, but we want solutions for 2 theta that are between 0 and 4 pi. So we want to include another rotation, another angle that terminates at the same place. We want to include another rotation. So to include another rotation of these, we want to also add 2 pi to get all of the possibilities. So we have 2 theta equals pi over 3, but it also equals pi over 3 plus 2 pi. 2 theta equals 2 pi over 3, but it also can equal 2 pi over 3 plus 2 pi. And this gives us all the solutions in our stated domain. So let's simplify those. So we have 2 theta equals pi over 3. Adding 2 pi to pi over 3. 2 pi would be the same as 6 over 3 pi, so add one more, 7. pi over 3. And we also now have we now have 2 pi over 3, and we're going to add another 2 pi to that. 8 pi over 3. So that gives us our 4 answers for 2 theta. Now we solve for theta. Divide by 2. Dividing by 2 is the same as multiplying the denominator by 2. So we have pi over 6, 7 pi over 6, 2 pi over 6. Now that can be reduced. Oh, I'm sorry. I didn't see. I did not move my paper up. Thank you. And 8 pi over 6. Okay. So let's reduce these. We got pi over 6 is our final answer. 7 pi over 6. 2 pi over 6, which is pi over 3. And 4 pi over 3. And this is our final answer. All right. Hopefully that'll help. And you can solve the remaining problems in my math lab.